Welcome back, everybody. Today we're going to be doing a little bit of review, converting fractions to different types of fractions and converting between fractions and decimals. So you're going to need notes 0, so your unit 1 vocabulary, and notes 4, which is titled proper, improper, and mixed fractions. So first, let's talk a little bit about fractions and some vocabulary. Rational numbers. A number that can be written as a fraction, a divided by b, where a and b are integers and b does not equal 0. Remember, if b, the denominator, is 0, the quotient is undefined. Terminating and repeating decimals are also rational numbers. A proper fraction, which you're probably familiar with, the numerator is smaller than the denominator, and the absolute value of a proper fraction is always less than 1. An improper fraction, numerator is greater than the denominator. The absolute value of an improper fraction is always greater than 1, and a mixed number, a whole number and a fraction, its absolute value is greater than 1. Pause the video and write down these 4 vocabulary words and definitions and examples on your paper. All right, so let's start talking. If you haven't put a 4 in the upper right-hand corner, please put a 4 in the upper right-hand corner. So we're going to start by identifying types of fractions below as either proper, improper, or mixed. So let's take a look at the first one, 24/18. Well, the numerator is larger than the denominator, so what type of fraction is this going to be? If you said improper, you're correct. How about B, 2/7? We see the numerator is smaller than the denominator, so what type of fraction is this? Did you say proper? You'd be correct. How about C? Well, I see a whole number and a fraction, so this one must be a mixed number. You try D. How about E? Is 8/8 a proper fraction, an improper fraction, or a mixed fraction? Think about that one. Well, the numerator is not smaller than the denominator, and it's also not larger than the denominator. There's no whole number and a fraction, and I know that 8/8 is really 1. So that just makes this whole. All right, let's do some conversions between improper and mixed fractions. On the left here, 2 5/6. To convert it to an improper fraction, we're going to use a strategy called checkmark. Checkmark, it means this. Multiply the whole number times the denominator, so this is multiplication, and then we're going to add the numerator. So 2 times 6 is 12, 12 plus 5 is 17, and the denominator stays the same. Let's try a couple. 1 times 4 is 4, plus 3 is 7. So 7/4 would be our improper fraction. Let's try B. The whole number 6 times the denominator 7 is 42. Plus 2 makes that 44. The denominator stays the same, so we have 44/7. You try C. Now let's go the other direction. We're going to convert our improper fractions back to mixed numbers. So if we take a look, we need to determine how many times the denominator divides into the numerator without going over. That will be our whole number. Then you're going to subtract that value from the numerator and place it over the denominator. So let's take a look. I'm going to color code here, and if that's helpful for you, you might want to do that as well. So the 6. The 6 is called the divisor. And the divisor goes outside the division box. Reminder that the 17 is called the dividend, and that will go inside the division box. Now we're going to start with our division here. So how many times does 6 go into 17 without going over? Well, 2, right? And 6 times 2 is 12. When we subtract, 17 minus 12 is 5. And so what we look and see is this is our whole number. Our remainder is our numerator. And our divisor is our denominator. And this gets us 2 5/6. Now, if you can do this in your head faster, that's great. But I wanted to show you this just to make sure you're clear of where it's coming from. So let's go through 2 more. 7/4. Well, how many times does 4 go into 7? 1 time. What's 1 times 4? 4. How far away is that from 7? It's 3. So 3 would be our numerator. 4 would be our denominator. Oops, I made a mistake there, not a 2. This is 1 time right here. 1 3/4. Let's try one more. So we have 7 as our divisor, 44 as our dividend. How many times does 7 go into 44 without going over? 6 times. When we multiply, we have 42. And when we subtract, we have 2. So our conversion to a mixed number would be 6 2/7. Exactly. You try C. All right. Let's talk a little bit more about vocabulary. So go back to note 0. Terminating decimal is a decimal that ends and has a remainder of 0. A repeating decimal is a decimal that has pattern and repeats. A bar is placed over the repeating values. Now, here's a place value review chart to remind you, of the different place values. We practiced rounding the other day. So when we're converting decimals to fractions, the easiest thing and the most helpful thing is to read the decimal itself. So if I look at number 1 here, I have 0.8, but we're not going to read it like that. We know that this place value here is the 10th place. So we would read this as 8/10. And we're going to write those words down, which means as a fraction, 8/10. And then we're just going to divide by 2 to simplify. 8 divided by 2 is 4. 10 divided by 2 is 5. And we end up at 4/5. Let's try again. What place value is the 8 in now? Well, it's in that second place to the right of the decimal. So that would be what place value? That's right, the hundredths. So this would be 8/100ths, THS. So when we write the fraction, it's 8/100ths. What can we simplify by? Yeah, we could by 2. Is there anything bigger that we could simplify by? Maybe 4. 8 divided by 4 is 2. 100 divided by 4 is 25. So we end up with 2/25. You try number 3. Now, number 4, remember the decimal point says and. So we have 1 and 25. What place value is that 5 in? It's in the hundredths place. That's right. So when we write this, this is going to be a mixed number so that the whole number to the left of the decimal is our whole number. And then the piece to the right of the decimal is our fraction, 1 25/100ths. Can we simplify that? Sure we can. We can divide by 25. What's 25 divided by 5? 1. And 100 divided by 25? 4. Exactly. You try number 5. We'll do number 6 together in class. All right, so now we've converted decimals to fractions let's go the other way and convert fractions to decimals. So let's read a little bit. To convert a fraction to a decimal, divide the numerator by the denominator until the decimal terminates or repeats a digit or block of digits. Use a bar to show the repeating digits. The denominator is the divisor, the numerator is the dividend. Now, these specific instructions say show the decimal to at least the thousandths place. So we want to make sure we're always following directions. But we're going to take a few notes to start with. If we want to write 3/8 as a decimal, we should be able to tell a couple of things. First, what type of fraction is this? Right, it's proper. And what do we know about the value of proper fractions? The value is less than 1, or the absolute value is less than 1. So as we see here, the divisor goes outside the house, the division box. So that's the divisor. What's the other one called again? The dividend, that's right, goes inside the division box. And now we just need to divide. Does 8 go into 3? No, it doesn't. So now we need to place a decimal in the dividend, and that decimal comes up into the quotient. Then we'll add a 0 in the dividend as well. How many times does 8 go into 30? Let's think. 8 times 2 is 16. 8 times 3 is 24. 8 times 4 is 32. That's too big. So 3 times 8, 24. Subtract, and we have 6. Well, we still have a remainder, so we're going to add another 0 in the dividend and bring it down. 8 into 60. Let's practice our multiplication chart tables. We're going to subtract. Well, we still have a remainder, so we're going to keep going and seeing what happens. 8 into 40, we know goes 5 times. And once we end up with no remainder, we know we have our quotient. So we have our final answer, our conversion, as 375. What place value is that? Thousandths. Correct. What type of decimal is this? Is it a terminating decimal or a repeating decimal? Well, it ends, right? We end up with a remainder of 0, so it ends up being a terminating decimal. Right. Let's try another example. Example 2, write 1/6 as a decimal. Okay, let's take some notes. Proper, improper, or mixed? It's proper. What do we know about its absolute value? Exactly, less than 1. Which number is the divisor? It's the 6. What's the other number called? The dividend. Very good. And so that's going to go inside. Let's do a little bit of division. 6 into 1? Nope. Decimal in the dividend, decimal up into the quotient. 6 into 10 goes once. Multiply. Subtract. Add another 0. Bring it down. 6 into 40 goes 6 times. 6 times 6 is 36. We'll subtract, and we have 4 again. Okay, let's keep going. 6 into 40 goes 6. Still 36. Subtract, and we end up with 4. What do you see happening here? That's right, that 6 is repeating. So we can stop there. We are to the thousandths place like the instructions say. We'll put the bar over our quotient here. This time it's not a terminating decimal, right? Because that 6 is repeating. So we're going to write it as a repeating decimal. You could also write this with the bar over both 6s, just as long as it's not over the 1, because the 1 is not repeating. All right. Let's try one more. 14/3 as a decimal. Okay, what type of fraction do we have here? Is this proper? No, it's not proper. It's improper this time. Why? What do we know about its absolute value? It has to be greater than 1. Now, if you can predict that it's improper and greater than 1, we should be able to set this up correctly. Because if I put the 14 here and the 3 here, how many times does 14 go into 3? It would go in 0 times, right? But you said it was improper so that it has to be greater than 1, which means we have our divisor and our dividend in the wrong places. So let's work that around. 3 into 14, how many times does that go in? 4. Multiply and subtract. Decimal in the dividend, decimal in the quotient. 3 into 20 goes 6 times. Multiply, subtract. Since there's still a remainder, we need to keep going. 3 into 20 again, 6. Now you might see that there is a repeating decimal here, but remember the instruction said to go to the thousandths place? So we need to divide one last time to make sure that we are accurately following the instructions. So we have our quotient. Again, you can put the repeating bar over all of the 6's, just not over the 4. And we have here a repeating decimal. Excellent. We're going to stop here for now. We'll finish that last problem together in class. Great job.